Students, Assalamu alaikum. Today we are discussing about the simplification of the mathematical questions. Before this, we have completed and understood the laws of radicals and laws of exponent. All these laws keep in your mind and revise in your minds. Then I will start the questions and stepping note that how I do the simplify the questions. Okay, now come to the question number 1 of the exercise. A very simple question. There are two numbers, 8 raised to power 1 upon 3 and 36 raised to power 1 upon 2. The power 1 upon 3 means first we find the cube root of the 8 and square root of the 36. This is very simple. 8, 2 4s are 8, 2 2s are 8, 4 and 2 1s are 2. That means cube root of the 8 become as 2. So we write as 2 cubes raised to power 1 upon 3. Similarly, 36 square root 6 6 are 36, 6 1s are 6. Square root of 36 is 6 raised to power 2 whole to the power 1 upon 2. Now, as we know that the power of power is always multiplied. So, here 2 raised to power 3 multiplied by 1 upon 3 multiply 6 raised to power 2 multiplied by 1 upon 2. Now the exponential form 3 multiplied by 1 upon 3 in this 3 1s are 3, 3 1s are 3. That means 2 raised to power only 1. We do not write the power 1. Similarly, 2 and 2 cancel. The number comes as 6 and 2 6 are 12 is the answer after the simplification of this question. Question number 2. 64 raised to power minus 1 upon 6. That means first we write 64 upon 1. As we remember, if a number having the exponent negative, we made it positive by the number change into the numerator to denominator and denominator to numerator. So it could be written as 1 upon 64 raised to power 1 upon 6. Now, in the next step, we find the sixth power of the 64. And how? By the LCM method, easy. 64, 2 32s are, 2 16s are, 2 8s are, 2 4s are, and 2 2s are. How many 2 comes? There are 6 2s come. Therefore, we write 1 upon 2 raised to power 6 whole to the power 1 upon 6. As we know that 1 is the number on which how many powers comes, it always gives the answer 1. That means 1 upon 1 raised to power 1 upon 6 and 2 raised to power 6 raised to power 1 upon 6, because power of power is multiplied. 1 has power, any power, that means it always comes 1, and 6 cancel, it comes as 2. The answer is 1 upon 2. Okay, now come to the question number 4 of the exercise. Now come to the question number 4 of the exercise. 81 x raised to power minus 8 z raised to power 4 whole raised to power 1 upon 4. First, x has the power negative, it made positive and it goes into the denominator. In the next step, we write the question 81 z4 upon x raised to power 8 whole raised to power 1 upon 4. If any power comes on a bracket, that means each and every term has this power. So we write as 81 raised to power 1 upon 4 z4 power 1 upon 4 x8 power 1 upon 4. Now, what is the fourth root of the 81? If we divide 81 by 3, so that means 3 2s are 6, 3 7s are 21, 3 9s are 3 3s are and 3 1s are. That means the fourth root of the 81 is 3. So we write as 3 raised to power 4 whole raised to power 1 upon 4. And now z 4 1s are 4, 4 1s are 4. That means z. Similarly, 4 1s are 4, 4 2s are 8. It comes as x square. In the last step, the fourth power of the 3 and whole power 1 upon 4, both are cancelled each other, and the answer comes as 3z upon x square. Come to the question number 5, in which 27 raised to power 2n upon 3, the exponent comes in the variable form. 8 raised to power minus n upon 3, it comes in the numerator, and in the denominator 18 raised to power minus n upon 2. First we made the positive exponent of the negative. That means 8 minus n upon 3 goes in the denominator, and 18 raised to power minus n upon 2 comes to the numerators. It could be written as 27 2n upon 3, 18 n upon 2, and in the next step 8 raised to power minus n upon 3. In the exponent, we are looking at, in the exponent the variable comes, but in the denominator the number is comes. That means first we find the cube root of the 27. It could be 3 raised to power 3 whole raised to power 2n upon 3. Now the 18, we find the factors of 18, so it comes as 2 into 3 into 3. That means raised to power n upon 2. 2 3s are 6, 6 3s are 18. Similarly, in the denominator, 2 to the 4 to the 8 raised to power n upon 3. It comes as 3 raised to power 3 into 2 n upon 3, and it will write as 2 raised to power n upon 2. 2 3's come, that means 3 raised to power 1 plus 1, it comes as power 2. We write as 3 square into n upon 2. Similarly, in the denominator, 2 comes 3 times, that means all the powers of 2, 1, we add it, base are same, it comes as 2 raised to power 3 raised to power n upon 3. In the next step, 3 of the denominator and 3 cancel, that means 3 raised to power 2n come. 2 raised to power n upon 2, and again the square of the 3 and n upon 2, 2 is cancelled, it comes as 3 raised to power n. In the denominator, 2 raised to power 3 and n upon 3, 3 cancel, 2 raised to power n. Both the 3 having the same base but different powers, as per laws we added the power 3 raised to power 2n plus n, multiply by 2 raised to power n upon 2 and 2 raised to power n. N means it has power 1, n, and in the numerator the power of 2. Numerator we are looking at this 3 raised to power 3n, but in the denominator 2 raised to power n minus n upon 2. If we take in 2 as LCM, it comes as 2n minus n upon 2, it comes as n upon 2. So the remaining power of the 2 is n upon 2, so we write as 2 raised to power n upon 2. This is your answer. If we want to further simplify, that means we write as 3 raised to power 3 raised to power n. We broken the power 3n into the 3 and bracket n. 2 has the power n upon 2. Now 3 raised to power 3 means it multiplied 3 times, it is written as 27. If we multiply 3 times, so 3 raised to power 3 means 27 raised to power n upon 2 raised to power n upon 2. This is your answer, and it also the answer according to book. Which one is given, you are checking. Come to the question number 6 of your exercise. Pure algebraically we solve it. First, in the first step, we copy out the term a raised to power p upon a raised to power q. The power is minus q minus p. We take in the negative sign as common, it comes as q plus p. Similarly, here a raised to power q, a raised to power r, we taken as negative sign common, r plus q. Similarly, the last term, a raised to power r, a raised to power p, and minus is common, the p plus r. The first step, we taken the negative sign common in each term in the exponent. Okay, now we are looking at the question a raised to power p upon a raised to power q. Both have same base, but they divide each other. In this case, we write as a raised to power p minus q first, and minus sign which is taken we common already, we put it over here, and p plus q, that means q plus p or p plus q, both are same. Similarly, on the next term is a raised to power minus common and q minus r, q plus r, because r plus q is written as q plus r. In the last term, a raised to power minus r minus p into r plus p, because all the additions are commutative. That means if we added p plus r and r plus p, both give same answer. But in the subtraction, these are not same. As the mathematical rules or algebraic formula, a minus b and a plus b, this is called the formula for the difference of squares, and it comes as a square minus b square. We use this formula in the next step because the negative sign is we taken as common, but the next two terms in the exponent, p minus q, p plus q, according to the formula p square minus q square. Again minus is common, and q minus r, q plus r. The formula comes as q square minus r square. Again r minus p, r plus p, r square minus p square. Here we write as a raised to power minus p square minus q square. Again we write as a raised to power minus q square minus r square, and again a raised to power minus r square minus p square. Okay students, now we come in the next step. In this step, we multiply the power of the a by the negative sign which we have taken as common. How? That means a raised to power minus p square plus q square, because this minus sign multiplied the p square is a positive number, minus plus minus and minus p square. Again we multiply minus q square by the minus 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 plus, we write as q square plus q square. Similarly, a raised to power minus q square plus r square, and again a raised to power minus r square plus p square. As we know that if bases are same, powers are added. So all these three terms has the base a. We write as 1 time a, and all the powers we added minus p square plus q square minus q square plus r square minus r square plus p square. Now, in the next step, minus p square and the last term is plus p square. Both are equal but have the opposite sign, so we cancel each other. Similarly, the plus q square minus q square as well as plus r square minus r square. That means it comes as a raised to power 0. As we know that, or we remember always, any variables or any number which contain exponent 0 is always equals to 1. So the answer comes as 1. Now on the question number 8, do yourself. This is your homework or home assignment. I will check it tomorrow how you can solve this question number 8 of the exercise 2.7. Do yourself. Try to do it, and remaining exercise we will do on the next class, inshallah. Allah Hafiz.